Well, welcome everyone. Thank you for coming to the Data Science Initiative. This is the first of our workshops for this quarter. It's an exciting lineup, all focusing on data visualization. Those of you who don't know me, my name is Pamela Reynolds. If you have any questions about our workshop or things are going on, feel free to come find me. You can also email datascience@ucdavis.edu. We love to get suggestions for workshops. So if you like this and have other things that are pressing or emerging in your field, or you're just curious about, let us know. We'd love to hear about it. With that, I'm just going to hand it over to Duncan, who's our director here at the DSI, professor of statistics and interim associate dean of graduate programs. Like saying all the titles.
Does that work better?
Yeah.
So, hi. So this is going to be by design and then by accident. It's very informal, and also this is part one of part of two. Workshops we're going to do on visualization. Okay, and today, like, personally, the best thing I could ever teach you is how simple. I had a conversation yesterday with a postdoc and an assistant professor about the ability to say no. I don't have it. So I was running around like a lunatic all week, and so I pulled this together. It's a little rough, but we'll tidy it up next week as well. But it's so this week and the next workshop on next Friday at the same time will be kind of a two-parter. We'll definitely connect. This one here, which is actually on Monday, it is by Gerald Kwan on genomics data visualization, and then Dan at the back will give a talk about creating graphics in R, kind of building very separately from this. This is about what we're trying to talk about here, which is something I don't think many people get to actually learn about, is what to plot, not how to plot it. And I am increasingly of the belief that many people are overwhelmed by software and just focus on the software. It either makes it too easy or it makes it become focused. So here we're intentionally today. There's no computer. I want you to draw. Okay, the old way, because it's a good thing. Okay, so then Dan will talk about actually how to construct graphics in R, and then Michelle will actually talk about geospatial data visualization, which is a whole world unto itself. I've also organized the theme of this quarter around visualization. We can go on for weeks and weeks and only hit the sort of superficial aspects of many things. Geospatial is obviously related to spatial data, related to data visualization, data analysis, but it's got its own world of complexity with maps, projections, and all these different things, and software. Then Jane, another postdoc here at DSI, and I will talk about interactive dynamic visualization, which you kind of need to understand static visualization and good principles, because then it's a heck of a lot harder to apply those good principles, because there's an extra set of things to consider when you're dealing with interactive plots, which we can now do so readily in your browser or your phone. That leads us to dynamic plots, where they're animated, where they're interactive in the sense of there's actually connections between different plots and different elements of an app and things like that. So what we're going to do is talk about how to do those in R in a simple way. What I mean by that is, we're going to just have an R package with an R function or two that actually allows you to create different types of plots, and you just export them. You don't know how they work. They just magically work. You put them on your web page or whatever it is, they're great. And now we'll spend the first half of that this workshop just showing you some of the available tools that are very cool. Now we'll open the hood up and actually see how they work. Okay, because it's all to do with JavaScript and web browsers and interesting things, which you don't need to know, but it's a useful thing to learn about, because then you can do with anything. And then Jay will build on that, again, hiding a lot of the details of actually how do you actually not open the hood up, but actually build these things inside in R with shiny apps and so forth. So that's what we're talking about over the course of the quarter. If you have any suggestions, I always think it's a good idea, especially I think everyone who's giving the talks is listed on the web page for the talk. You can send them an email to say, hey, I have a really nice data set I'd like you to work with. Okay, we're open to suggestions. Again, especially next week, if you go say, hey, let's try to actually visualize this data set. So talk to us if you don't want to mail the you can't find the person mail who's giving the presentation. Just mail data science at UC Davis and say, hey, I like that. Talk about this. Oh, yeah. So this is like all we do is maybe not go away. So I just have this. I have these. So many of you have taken a class on logistic regression. So how many of you have faced logistic regression? Okay, pretty much it's the same people who took the class, which is good. I don't like people filling logistic regressions. If I pull up neural networks here, the number would have gone down, but hopefully it would be the same, 1-to-1. Okay, which is I took a class. I used it, that's fine. Okay? How many of you have taken a course in visualization? See where I'm going with this? So how many have actually created a scatter plot with 3 variables? Okay. Pretty much all of you. Okay, this is weird to me. This is kind of, I get in the way. I get to rant. I get to walk around and rant on some of the things these days. I'm probably do that a lot today. It's just kind of strange. In fact, actually, I bet every one of you, I can't say this, I didn't grow up. Half of you didn't really grow up. Coming from me. Half of you probably did actually take a class that actually introduced you to some visualization, probably when you were a math. Okay, so it's that. Okay, it's just that it's in our vocabulary. It's easy. It's very well. You probably have to draw a bar plot. Keeping up my daughter data, so you drew a bar plot of data points that we started and you did and run things which gave you a histogram. Maybe you look at a scatter plot. You've taken some visualization, but not a lot. You don't teach it in data analysis and statistics. We don't really teach it. Of course, we don't teach enough data analysis. In our stat class, we focus on methodology, and we certainly don't teach, in my opinion, enough visualization. So it's funny. We're all used to making visualizations. I suspect if I also have, how many of you have created 2 plots this week? Many of you have fitted 2 logistic regressions this week. We do it all the time. We do it for so many different purposes. So it is kind of actually a little odd. So I just asked. So what I want to do is I really want to get away from how we make the plots. I really want to talk about how you think about making plots, and I really want you to start thinking about how you make plots, and why. So I want to step back, and I suspect all of this is completely obvious, yet it's not. But if nothing else, even if it's obvious, I want you to just take 2 hours to actually reflect on this and say, I should do that more often. Okay. So the learning goals are basically saying, what are the roles of graphics in research data? And then we're talking here about, by the way, we're talking only about data visualization, not talking about information visualization, scientific visualization, with vector fields and so forth. We're only talking about the data analysis purpose, but that's very important in terms of, as we'll see in a second. Okay, I want you to think about how to compose a plot, not how to create it, but how to compose it. Okay, if you have a piece of paper, draw it out and say, that's what it looks like, that's what I should implement. When we write software, when we write code, that's what you do. But that's just pretend you do. Okay, which is you should actually say, this is what I need to do. I've broken it down into tasks. I'll implement that now. Anyone who sits there, I'm going to do this myself, so I can point fingers. Okay, I just start typing and go, I know what I'm going to do. Let me stop for a moment. Okay, that's when I waste a lot of time. For some reason, again, correct me if I'm wrong. It's an opinion, so but it's okay. This is part of the problem. But most people don't. They seem to leap into writing code, and there's a reason for that. Good reasons and bad reasons. So I'm just going to say, I want you to think. Okay, about the composition of the plot. Okay, and we'll talk about the different plot types. We may get to bits of it today, bits of it next week, when we can talk about various different things. And then we'll talk about principles for the effective use of graphical elements. What elements do you put in a plot? Lines, circles, different types of glyphs, and so forth. And why do you choose one over the other? Okay, so color, how do you use color? And these things actually have some principles. We tend to do them by, that works, or that's what the software did, so why not? Okay, and hopefully the software embodies good defaults, but not always. Okay, and then we'll actually talk about graphical elements. So many of you will know about ggplot, which is an R package, which is the GG and ggplot comes from the grammar of graphics, and it can be helpful, not essential, but it can be helpful to actually think about a grammar of graphics, so that you can actually break it up into it's native elements, and you can make any plot from these native elements. This is a nice book that Lee Wilkinson wrote, which makes ggplot 2, and so it's got principles to it. It's a little bit less sort of not theoretical, but an actual sort of a unified theory. Okay, so what else do I want? I want you to think harder about each plot you create. I should have you sign that. But you know that you will take 5 minutes before you make any plots. Let's be practical. Okay, we'll give some rules of thumb, or when you're considering a particular plot type, which should you use? Okay. I will actually encourage you to do this. I find this again. I hope I'm wrong. I certainly see it a lot, so I think so. Maybe you're all different because you're yourself selected. But just a lot of people just make plots and stuff, and it's like, when was the last time you wrote a sentence that you wanted somebody else to read, and you just wrote it and stopped, and never tried to edit it out? Okay, never tried to edit it. Yes, it's for your own purposes, great. But this is very much like writing. It's a very iterative thing. You may end up having looked at something and said, that's not the right thing, I can do better. Okay, do it entirely differently. Okay, so don't necessarily make traditional plots using the software defaults. Think about the details of composing a plot, and importantly, this. And again, it goes without saying. It seems to go without doing too. Okay, again, I will be like a broken record. What's the purpose of your plot? This is critical. If you don't know what the purpose of your plot, and I see this a lot. And again, I'm thinking very much of the undergrads, where they go, how many plots do you need in your report? 4. Okay, it doesn't matter where they come, it doesn't matter what they're for. I need 4 plots exactly. Question. Okay, I mean, this is an issue, and also I've seen it in papers too. Published papers where you go like that now, gratuitous plot, which is important because I know the reviewers will say, where's the plot? It's not a plot, but it has no relevance. This is like putting a paragraph that's completely unrelated to the text, or certainly that's irrelevant, but it may be related, but it's like, well, what's your point? So if it's an evidentiary point, then it has a particular purpose and it needs to have particular characteristics. The purpose of the audience is probably going to be very closely intertwined. Okay, so to me, if you're trying to write a paragraph or 2 pages, first you better figure out who the audience is, what they need to get out of it, and how skeptical they're going to be about the things you create. Do the plots actually provide detailed evidence, or do they actually just provide a big picture summary because everyone believes you? Okay, or are you actually asking a particular question with your plot that you need help on? So the purpose of the audience, they go together. The message, you got to compose that message. Okay, what's the purpose of it? The purpose of the message is slightly different. And this is really becoming a pain. The wonderful thing about these things, is now people look at plots from things that, as I go home, I have 3 monitors that are 5K, 4K monitors, and I can see everything that I can possibly see, and then you've got people, projectors like this. We've got a bunch of different media that you actually have to take into account, and you have different characteristics and colors. So the plots that you can actually draw have to be sort of, potentially you need the same plot in modes in different ways for different media. That's the thing. Okay, so as I say, this is natural. It seems to be everyone seems to get it. We never have to take a class, and we're making plots left, right, and center. So clearly, it's just okay. But as I say, I think there's a lot to creating a good display in my mind. Okay. One of the problems I think is it subjective? It definitely is, because what we see is slightly different from what everyone sees. There's probably some cognitive scientists here who know that's a lot better than I do, but we all see slightly differently, so you've actually got to take that into account. That's why you have to actually figure out your message and make sure the message applies. But how do you actually decide what's a good plot? How do you decide what people are actually how will they extract the message? And it's somewhat hard to come up with good criteria to evaluate plots, kind of, okay? But probably, again, there's just so many different purposes to the plot. So if you don't know what the purpose is, it's very hard to pick the right criteria, okay? But that's why I just say, step back and say, does it achieve its message? We do the same thing with writing. You know, has it achieved? Did it get the point across? We can figure that out. We know what the message is. We can figure it out. Same thing with a plot. If you actually take the time to step back. But again, I'm not sure enough people take enough time to actually figure that out. Okay. So you know, we've got this complexity. That is definitely a thing. So you need to think about these things. You can argue, and we can have wrestling matches or arm wrestles about these things, about whether a plot's good or bad or worse. But we want to try to get some principles, or at least you've got to be able to justify with some serious thought, as opposed to actually saying because I think so. Okay, so you got to figure out why you're showing the plot. Okay, we can talk about this if you want. But if you're depending on it. Basically, what I'm trying to say, I have some notes of these, and I'll post these later on. You can see the notes, so I try to explain a little bit more of this. But in my opinion, if you're going to your PI, well, first of all, we'll get to the moments of the versus, I'm trying to remember where it is. It's just right here. Okay. If you're cleaning the data, for example, okay, so you wrote a data set, somehow you've got this data, you clean it. You're probably looking at the plots for you and no one else. Okay, this is an internal thing. You have a totally different purpose than if you're actually going off and actually sharing it with your collaborators, you know, PI or whatever, and saying, hey, does this look right? Why is this funny? That's a different purpose too. You've actually got a question that you're trying to ask that person. You're trying to get an answer in the most efficient way back. They have to see things. Whereas when you're just cleaning data, it's all about you. Okay, potentially you don't need to worry about putting labels on plots because they tend to be very, very ephemeral. They tend to disappear after about a minute because you just make the plot, look at it and go, that's okay, there's nothing to see here. Okay, a lot of what you're doing when you're cleaning data is actually just finding errors in the data that was input, the actual content of the CSV file or whatever it is you're saying, for some anomalies, which typically are inliers or outliers, and that's a very, very, very tricky operation to do because you basically got to spend the rest of your life looking for any possible error, which could be one of a billion and more different combinations of things to look at. So you're gonna stop after a certain amount of time and say, I think they're clean, but this is a very different purpose than if you're talking to your PI and you literally want an answer about a certain thing. Could you explain that, or do you think this is an error? Then you need to actually sort of use them. If you're writing a paper for your colleagues who are going to be skeptical because that's what we do. Okay, research paper. When you're writing a thesis, okay, you're going to have to. In some cases, you're going to want to actually just show the big picture and say that's the big picture I want to take away. In other cases, you're going to have to provide minute details to actually provide the evidence that justify the claims. Okay, so these are quite different. These are quite different. And so how are you depending on it? In one case, it's evidence. In the other case, it's actually part of the text, if you will, part of the message and the big picture. Okay. In many cases, I've seen a lot of just gratuitous plots where it's just not clear that they're there. Likewise, I see a lot of gratuitous tables, and then they say, see the plot, and you go like, well, which is it? Because the same data is in both, so you don't get to actually write the same paragraph twice. Okay, so that's so what do we do? This to me, it's important to recognize that it's obvious in some regards, but that visualization comes in everywhere. What I'm trying to get at here is that visualization behaves. The purpose is different, how we do it, and the goals are very different. Okay, cleaning data is one particular thing. Exploratory data analysis, the EDA as we call it. Okay, this is for different purpose than cleaning, and yet they tend to go hand in hand simultaneously. You're doing both. As you're cleaning data, you're actually seeing patterns. You're seeing the patterns that you're seeing the things that don't match the patterns, which means you're finding you're finding the errors and so forth. But this actually is to summarize variables, summarize relationships, which is quite different from actually trying to find the odd ones out. Okay, and trying to find errors. Have you ever heard of this term, confirmatory data analysis? You've heard of this term? Where did this term come from? It's EDA. Famous book, a big bright orange book. Written by a guy called Tukey, John Tukey, very famous statistician, mathematician, and so forth. And Tukey came out and coined the term EDA right back in the 60s. It was very much, it was a philosophical difference in terms of what statistics was about, because there's so much theoretical statistics going on. Like, hang on a second, there's a big bit missing. EDA is a big component. And Tukey also coined the term confirmatory data analysis again, which is you don't just fit the model, you actually then start doing the whole process of trying to figure out what's wrong with the model by looking at residuals and diagnostics and actually confirming whether it's correct, whether it's through validation mechanisms or so forth. But this whole iterative cycle, we all know this, but it's got a term that isn't as widely used as EDA. But again, it's a different purpose. Here, you're actually, it's very much like EDA on residuals. It's related to the models and so forth. So you're off doing this. And, again, very, 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 very iterative. When you're communicating findings with about 3 different people you can think about, say your collaborators, this is where you're not just communicating to yourself, other researchers in your field, presumably, and then people outside your field. I suspect here you actually are trying to get across general science and big picture results that people believe you and they don't want to know the details of what you do. Okay, they want to know the big thing that's you're credible, but these guys are probably highly skeptical, so you probably do need to figure out how to minimally get in as many plots that actually prove your point, so that the reviewers can't come back and say, did you try this? Did you try that? Okay, or I don't believe you. And this is one that most people don't seem to, if you ask people about where does visualization come in, they don't think about it so much. A lot of people we're talking about writing code. Okay, so doing software engineering, we don't tend to do a lot of visualization for software engineering. Or if we do, we have very specialized tools for software engineering, which is to look at code, the entire collection of files and functions in files and so forth. But what I'm talking about here is when you write a line of R code, a Python code, you tend to do it iteratively and interactively, where you just write a line of code, you get something. I say to all my classes, I've been doing that for 25 years. I know the language, like the R language, like back of my hand, and I'm almost, I can say almost always, like every line of code, I typically actually write another line of code to check the output of the previous line, because I don't trust what I'm doing. Okay, it's usually I'm doing something really simple and stupid. How the heck do I do that? Okay, I'm doing something slightly unusual, so I do it now to check the answers. And how do I check the answers? Well, I got 1,000 things. So what I did was actually a big data set, split it up based on some other variable, and then I wanted to know how many things are in each of those. So I can do some little summary statistics. But I'm getting back 1,000 values. I need to see those values. So I look at them. They look typical. They don't look unusual. Therefore, my code is probably okay. Okay, it's much easier than actually going through programmatically and checking that I got the right answer. I'm going to actually do some nice summary statistics to actually check. Do the things satisfy my expectations? So I use this all the time, and it turns out, again, not enough people do it. And people who use R and Python tend to do a lot more of this because they're doing data analysis anyway. So they do the data analysis on their output of the code. So it's a kind of, whereas other people would actually have to building a lot of functionality. So these are the steps involved there, but hopefully you agree. Again, it's obvious, but maybe not. Maybe it's too obvious. It's just too early. Is there a different purpose for all these things? And does it matter?
if these are the five or six different steps, does it matter? Or do we still use all the same visualization approaches? What's the difference? Anything concrete?
We don't have time for that.
And yeah, that's a good one. I mean, that one, this one, how much how much time you put into making each plot? Again, so let's be very specific, because this one takes forever. This process takes forever. Okay, and then this process takes forever again. So that's a lot of hours, but but each plot here is pretty quick because you don't care, because you're kind of looking for big pictures. This can get nasty. This can actually start getting into very tricky, because the plots you're looking for are actually probably going to be atypical, because you actually have to go in and annotate. You actually have to go and annotate a plot and say, what point is that? What point is that? And then go make another plot and say, highlight those 2 points and go, wow, that's weird. We have tricks for this, okay, which is actually, we had tricks back in the late 1980s for this, and they're now only becoming back there, now only coming into resurgence again, which is linked plots, where you actually have interactive visualization. So you can actually click on a point and say, hey, show me that in all of these other points, all these other plots, and that's good. But these can be very atypical plots, so they can actually take time. But now you're actually going in and annotating individual points of attention or just finding them. So it's the length of time. But as I say, I suspect it's actually that you're composing different. You should be spending more time thinking about what the purpose of the plot is. Okay, in the audiences. You may end up with the same point of plot, and that's the bit that bothers me. Even after hours of thinking, you may end up with exactly the default plot that you would have created ahead of time. But okay, I think that's too easy. Okay, I think I'll show you some plots where the whole beauty of them is that they're non-standard plots, and the fact that software is getting easier to use is a double-edged sword. It means that we tend to end up with the same old boring plots. That's a good thing because everyone's familiar with them. But the fact that software is actually easier to use means you can start making some really powerful plots without too much effort. So one of the things I want you to think about doing is how do you make totally different types of plots using the same basic building blocks, but how do you actually start coming up with get your creative side. How many of you are in STEM? Okay, so this is your opportunity to do the creative side. Just tied to data, still appeals to one side of your brain. It can be good. Okay, so this thing. And so before we start on plots, one of the best plots is a table. Oh, sorry, I love to phrase that again. One of the most common plots is a table. Rarely is it a good. Rarely is it a good display of the data. Okay. What's the purpose of the table? It is very, very different than a plot in many, many cases. Some plots we really care about being able to look at the stuff. And then I was just talking about with cleaning data, we actually look at individual points and we annotate them. So you're kind of annotating the outliers or specific points. And that's fine depending on how many points there are. We may identify all of them or just a few. Okay. In this case, and you see the rough relationships between the observations. In this case, in a table, you are actually, it's for lookup. You are actually giving them essentially a spreadsheet and saying, if you need to see decimal places for this value, we're going to look it up. Okay. So that's a very different thing than the intent of actually summarizing the values. Okay. So first of all, we do see a bunch of this, which is if this is your data set, for example, male is 42%, female is 54%. Okay, there's two different categories, 2 values, and you're going to give up about 3 square inches of a page or something like that to actually display these 2 numbers. Not a good use of space. Okay, this is what this text here kind of gets across the point pretty quickly. So there's no point in actually using a table or plot or anything for 2 numbers. Okay, especially if this was 42 and 58. You go like 42. Okay, one group is 42, the other is the rest. Okay, I don't really want that, but there's a very famous plot I can pull it up if you want, which is like that. There's a guy called Edward Tufte who Andrews did a lot of critical visualization early on, late 80s, late 70s, early 80s. And one of his most abhorrent plot that he's found is this one, which is, when you see it, that's just going up. It looks something like this. Point here, point here, point here, and a point here. And there's this, which is a complete mirror image of this, because these numbers add up to 100 at each of the 5 points. So it's completely real. But this is an extraordinarily disgusting color, green, matched with an even more vibrant yellow. And it's like, wow, that is a complete waste of space. There's just nothing good about it in the sense of composition. But there's so much cognitive overload to actually read. And to look at. So there's time for 2 or 3 or 4 points, and you can put it in a table or you can put it in text. Okay. So there's a general principle. Here, there's a paper that Andrew Gelman, a well-known political scientist and statistician, very much established in both, has a paper on, hey, we really should do what we tell everyone else to do, which is not present tables in our statistics papers, and then tell everyone else to make plots. So he actually goes through. It's a nice paper that actually just shows how you can transform complex tables into much better plots. Here's a table. This is from Andrew's paper. What you pull out here. So this is where you get to work. That's it. I mean, presumably there's a bunch of text around here that describe what's in the table, in which case why have the table. What's the message? You can ask me questions about it to give you context if you want.
Frequently, Russian publishes things.
Yeah, it's the citations in the publications, how many times they're cited. Mm-hmm. And so you have these a different set of fields or disciplines or professions. Okay, and you got the frequency, and you have the number of people who were employed in that. So you do want to have to adjust it based on the number of citations in there. It's going to be related to the number of people employed in that field. So that's good. So, which group has the smallest number of citations per employee? Quick. Okay, which one has the middle? The programmers are obvious because you didn't even need data for that. I consider statisticians. Statisticians are okay. So they're very small numbers. We have to do a lot of gymnastics here. So all I'm trying to get at here is what are we looking at here? Because this is what the purpose of a plot is. It's to try to actually get a message across. What's the message? This is hard for you, but certainly if you can't get the message quickly, then these guys have failed with this table. So this is our way. This is just one plot. Okay, one interpretation, one mapping of that table over into a plot. So there's your statisticians, number employed, very small, number of citations, very small here, the computer programs. They're not quite below as somebody yelled at. They're still low, but they're in a different quadrant here, if you will, because Andrew's added in these lines, which actually help you demarcate probably one citation per 100, per 1,000, per 10,000. That's good. So this is just, there's very few professions, so we can just annotate the points. We don't do this, partially because we run out of real estate. Nowadays we can actually put tooltips so we can hover over these things and pull up all sorts of other things. It doesn't work so well on a printed paper. This is the issue of the medium that you have to worry about. It's like, hang on a second, I'm going to put this on the screen, I'm going to put this in a paper. I've got to think way harder as to how to get that extra information on. Okay, so you probably have to throw this plot away and start all over again if there were more observations here. What else do you notice about this? So first of all, let me just say, what do you notice about this that is not standard? There isn't a one-line command If you just said plot X comma Y here.
The data labels?
The data labels, you have to go and intentionally put these on. You probably have to pick out where to put them, center them, right align them or not. Let's not worry about that, but you have to actually say, I want the data labels because they're not normally there. What else isn't normally there? The lines, the 3 lines are chosen to actually to indicate something. We're composing a plot and really trying to actually focus people's attention on a message here. Okay, it takes time and thought. I mean, this, you look at this, presumably you, the owner of the data, know a lot more about this, and it's going to be a lot faster than if I asked you to just sit down and do this right now. But, so context is absolutely essential. But there's a lot of thinking to go through this, probably a lot of trial and error. I'm pretty certain Andrew and his group went through a lot of iterations on this. Okay, so we've explicitly added this, explicitly added 3 lines. Why 3? Makes sense. Why does it make sense? Yep, covers the data. So that's a good one. But it's very much because we don't put in 10 lines regardless. Okay, I like this idea. I'm always going to put in these diagonal lines. I'm going to have 10 of them regardless. And it's like bingo. I've now come up with a new type of plot. Okay, and we can go ahead and do that. They're adjusted, but they actually, if you look at the labels, we also have to put these labels on. If anyone's done this in R, you know how annoying this is to get the text out of the box. It's not hard. It's just like non-standard. Again, it's non-standard. Okay. What else is going on here?
I think it's a standard approach to think low, medium, high, like for your average reader that knows nothing about the topic. So there's 3 categories.
That makes perfect sense. And this is the other thing that I've got a bunch of notes written down here saying there's much more. Just it'll be more clear if you read, if you look at it. When I talk about them. Yeah, you really want to appeal to people's notion of just as 3 categories. I know what I'm expecting. I am anticipating what you mean. It's medium, low, high. That sounds good. Okay, we've only actually really got 2 groups here going. So because they're not outside of here, so we've only got 2. But one of the you want the principle of least surprise when it comes to user interface design, and user interface design is plotting as well. Okay, and that is if something looks like what you think it is and it's not. Oh, you really confuse the person. They're thinking, oh, I understand this, and for some unknown reason, people think plots are supposed to be easy to understand, so they just immediately just say, I understand this. That axis must be this. So there's the first couple of pages of a book by Howard Wainer, who's another tough-like person who writes these books about bad graphics. He has a nice plot of smokers versus non-smokers and likelihood of dying at different ages. It was a boring plot. It's a statistical plot. It's a scatter plot. It joins the lines and shows to everyone. So look, it's blatantly clear that smokers die at a higher rate. And we go, oh, your plot's hard. So eventually they ended up with 2 plots, with another plot. He went through several iterations where he had an axis here and an axis here, measuring the same thing, but on different scales. And now the effect goes away. And it looks like smokers actually are more healthier because everyone leads from this axis, but in fact it's related to that axis. It's the stupidest thing in the world. I mean, none of you would ever think to do this. It's just some people do, and some people want to lie. And that's by the way one of the things that the given here is we are going to be faithful to the data. The principles of making dishonest graphs are totally different. Okay, it's just a game. Okay, in university we don't go for making stuff up. Okay, but so going back to what else is different? Yep.
There are log scales.
There are log scales. Okay, and that's why we actually got the 100, 1,000, and 10,000, and that's why we got the 3 bins, because that this is the data, as you say, we're all poking around the same thing. It's if the data naturally fall into these groups, but only on a log scale. If you just plot this regularly, you're going to lose so much information. How many of you know how to read a log scale just like that? Yeah. I have to think. And this is not, it's not, some disciplines it's just, it's built in. I mean, because everyone just does stuff on the specters. Your field, everything's on a lot of scale, it's the strong. This, but it's complicated to actually. So if your audience doesn't know how to read log on scale, there's a huge cognitive burden. So now we're like, this potentially may actually be better. Okay, again, you got to know your audience and say, is it actually going to get the message? My biggest concern, the thing that I try to actually preempt when I'm making plots is, how can somebody misinterpret this? Okay, what can they do and to actually misinterpret this, and then so can I actually contend with that? Can I put a note in that actually prohibits them doing that, or can I actually make it so atypical from what they see that they have to think they don't actually make that mistake? So so this is just one example. Andrew's paper, as I mentioned here, Andrew's paper has a bunch of these, and they're kind of useful. I do remember. I just read Andrew's paper. We all knew that, but we all knew that tables and plots. But Andrew took the time to write that. And I saw somebody in the old days giving a talk with overhead slides, and went through 12 slides, which were one table. And if you think about that, I have to remember what was on the first page and compare it with the thing on the 12th page. Impossible. I mean, it's just the cognitive overload is just absolutely too much. So one of the really big things is things are not close together. I mean, when we look at this table, is what are we drawn to look at? In this particular case, maybe are we looking row-wise or column-wise? These things are close together. Is that appropriate? Are they ordered in this particular way? Are they ordered? Which variables should they be ordered? There's a principle that says if you want people to compare stuff, table or plot, put them beside each other, because if I have to run from one end of the screen to the other end of the screen, I've lost my context. It's very, very hard to measure distance or height if I actually move my eyes. Okay, somebody get that.
Is it okay to something in a case like that to have both the table and the plot? Because the things that if the audience is not used to log, just the log scale, they may be just there's this rejection at first. So it's too complicated.
It's okay. I mean, so yeah, this is why I put that slide up that says, hey, this is hard. It's subjective. Okay, it's more to the point. I don't think it's subjective. It's just that you're trying to use the same plot for multiple audiences. So if you tell me who the audience is, I'll tell you whether or not they should be able to do a lot of that. For your thesis, it doesn't matter because your thesis can be infinitely large now and do it electronically. Okay, so and also there's no page restriction, so it's present. Okay, but for a journal article, they're not going to be very happy that you just repeat the same information. It's like having a paragraph that then says, you know what I said in the previous paragraph? Well, let me just say it a different way. Okay, that will get cut so fast. So you are repeating stuff. For some unknown reason, it does tend to actually get done. Do you need the whole table up? I mean, can you actually use the plot and then actually put in a subset of the table? Or something. Again, you can use both together. You can have two plots. So therefore you can have a plot and a table. But you can actually combine the plot. But I think a lot of people just say, here's the table. Here's a visualization of the table of the data. And they don't actually think, hey, this is part of a composition of text that is actually making a point. So it's tricky. If your audience, in my mind, if your audience, who's reading your stuff that doesn't know about how much scale?
Even audio researchers in some areas, they have these immediate rejection to log. They say, oh, our mind is not prepared to.
So this is also unfortunately we're going to get into this. We're going to get into this again because I'm going to go on a rant very soon about something. Part of it is we have to educate people. Okay, but again, I mean, you've got to pick your battles. Who's your audience? But these are researchers who should know about that because it's part of the work that they should be doing as well. This is a vocabulary lesson for them to actually start doing. But it is hard. Okay, but if it's a general audience, don't waste your time. You know, you're not going to win that one. So now you're going to just annoy people. You know, they'll just ignore what you're saying. You know, who knows? But there is this aspect of actually, we're a bunch of researchers. We should actually do that. Okay, so I got a plot handed to me a few days ago by people I work with in my other office. I have them in my bag. I almost use them today as examples. But you know, it's a different model. But in research, we do actually want to advance the state of the art. We have sort of improve, in my mind. Okay, so this is the other thing about the same about plots too, but especially about tables. Is you say, here is your table, see it. Okay, we have captions for these things, and the caption should say what they're seeing. But a lot of times people don't. They just say, you interpret. Okay, you interpret what's there, and yet you've given up this opportunity to actually make your case and to actually guide them. And there's no reason why two people will look at a table or a plot even and say, I see the same, focusing on the same thing. That's why in plots we're going to get them. We're going to try to figure out how to get them to focus on the thing you want them to compare by putting them close together or making that the primary element of the plot as opposed to the fifth level element. Okay, so you've got to decide how to grab their attention. Tables are hard that way. Okay, you can do it with tables in certain ways. They're just like organizing the rows and columns and putting many lines in between segment the blocks into different cells with multiple subtables. But that's where you're saying focus on this separately from this. You can do it, but you better actually do it, because otherwise you're giving up a whole lot of arguments and opportunities to actually influence what they're thinking. Chart jumping. Ever heard that phrase before? Another one of Tuffy's phrases. Chart jumping. We hate chart jumping. This is a good example of chart jumping. I'm going to give you this one. This is not good. It's not bad. It's appalling. Okay. So how many observations are there? 7. Mm-hmm. How many numbers? 7. So you got for each observation you got 2 things: the date. Okay, and they are sequential because they roll this way. Okay, it's like okay, that's a little weird. So what's wrong? What else is wrong with it? Well, what's right with it? Which was the biggest month? This is actually January. Okay. Which was the middle month? So to get this right, you actually have to scan every single number. Yeah. Subtract them essentially from each other, find the point. Okay, so this is hard. Whereas if I drew a plot, so what plot would you draw? Let's start figuring out how. I say again, I want to draw today. I hate giving up on computers. How? What would you do to make that more effective? We'll talk about what we mean by more effective.
I mean, even a simple bar plot would be more effective.
Even a simple bar plot. Okay, so what's a bar plot?
So dates would be along the bottom.
I mean, again, sorry for belaboring this, except for I see it all the time. And by the way, we're not going to use a bar plot. But I know everyone's going to go there, so we'll go with the bar plot. So here's the date. So we're going to have January, February, March, April, July, and
it says rates, but it doesn't give us a denominator. So yeah, whatever.
These people are challenged. Okay, so this is going to be, let's call them counts because they're probably not holding. Okay, so then we put counts and then we have a bar plot. So what are we going to do? So we're going to put a value up here. So this is 536. So let's put this at 550, let's say, and we put a value here, and then we put a bar. Okay. How wide should the bar be? 5? Okay. In terms of pixels, yep. Okay. Again, this is so. I just see these all
all the time. Okay, so we'll get to this later on. But this width, what we're actually doing, of course, is encoding something. This is a height. This is a distance, a length. Okay, any of them. It's a distance. It's a length. The distance from here to here. It's a length. Whatever. Okay, we're encoding the information in the length here. Okay, is the value 536, and of course, then we put the next one is 467, and we get down to here. Okay, and whatever it is. I'm making this up. See at this point. A little closer. Okay, and so forth. Okay, so we see this. How wide should there be any gap between this and this? We talked about how wide the bar should be. What's the gap between the bars? 0 or more than 0? Why? They're consecutive. The second January's over, February begins. You just saw. So why is there a gap? It's time series. Why? It doesn't. It makes them further apart. Didn't I just say put them together? Like, as close together as possible? Okay, well, we'll put it over here. We'll move February over here. Now you kind of do an awful lot of work to get over here. So why should we separate them?
It's not continuous data. It looks like it's around convections.
That's my argument here is, then I'll think it's a histogram. It is a histogram. Maybe not, because they're not equal number of days. You could argue that. But I think the biggest problem is people will think it's a histogram, and now you may be in trouble because this is the aspect of least surprise. I thought it was a histogram, and then you say, what's the difference between a bar chart and a histogram? And outside this university, they'll go, there's a difference. What's a histogram? Okay. So there are some interesting principles here that you have, again, I think, that we never talk about, which is if you close the gap, it makes perfect sense to do that. But if people then interpret it as an area, which they will, if they think it's a histogram, this is based on 31, and this is based on 28. Okay, leap years. Okay, look it up. Okay, and all that stuff. Does it matter? Probably not, especially if they think they're rates to start with. This is not necessarily perfect, but this is fine. So why do we not prefer this? Why do we not like this bar chart? You know, we have all these decisions that actually have to compose it. By the way, if I want to compare, if I wanted to, what else could I do? If I want to be stupid, but if I want to actually show, I want to show people which were the biggest months. What else could I do? Ooh, color code. And now we get into colored bars. Okay, we can color code. I mean, one of the problems is that I can just see this. You know, if it goes back up here, I can just say, you know, one of the things I can actually do is I can draw a line between them, which will actually help accentuate the difference, because my eyes will connect the points. And if I actually draw the points in here, and because there's only 7 months, if I really wanted to, I could put in 5, 3, 6. We have all these choices. There's a lot more work to be done here, but this is a choice. This is composing the plot. We have to decide what the purpose of it is. Do we just want to actually show the general trend? Do we want to just show? Do we actually want to connect dots? Do we want to show the individual values? These are all different audiences, different purposes, different messages. If I put these values in, I avoid that problem of I don't need to show the table, and people can actually look at the values very quickly. Okay. But, so we can color code, we can color code the bars. I'm taking your name later on. Again, the bars don't, that's the trouble, okay? In this, if it's a histogram, they do, then they represent the number of days. And we could easily make this a good thing by actually making this 31 units wide and making this 28 units wide and actually make it a histogram. That would actually be quite sensible because time is continuous, okay? But otherwise the bars don't actually mean anything. They're equal size. So the only thing you're actually representing is length. One of the principles of this, in my mind and in people's minds, is if you've got one variable, you probably shouldn't have 2 dimensions. Okay? We've got 2 dimensions because we've got 2 variables: the date and the count. But we got a third one, which is the width here, which comes from absolutely nowhere. Okay, it's
It's just an arbitrary. If you wanted to put color on these, you'd need a bar because it's very hard to see that color with an infinitely thin line. So we could draw a lollipop plot. Okay, so, so when we actually have this, we just have a line on it, we could color code this. But the trouble with color coding that is it's really hard to pick up because there's only one pixel wide or something like that. So that's a cognitive problem. But again, this is the value, so it's not clear we need to repeat it again by color code. And if we do color code, we got to actually have a legend somewhere. Oh, this is getting out. Okay. So these are kind of this is good. This is kind of a wacky block. What's wrong with this?
The last one, I still have a question. What do you really need just like a static block? Like, because we need the full bar and just to have points.
So there's.
And no lines like you've got to see lines.
So we've gone from.
Just one point.
My argument about almost everything here is the word dot chart or dot plot, depending. Because this is extremely flexible. It grows with your problem. Okay, this is for Austin, Texas. If I have Davis, California, how would I do this? If I'm going to do a bar plot, what would I do? Be very careful. I know what you're going to say, so just tell me because I want to get it out. So I'm leaping ahead, and that's exactly kind of what I want to actually do with this. This is very informal. I could put another bar here. Now I definitely want spaces in between them to actually group these. All makes perfect sense, except for everything makes perfect sense if you start in the wrong spot. Okay. And I say I'm going to belabor this because I think it's something else as well. So you could actually draw it this way, and then of course, if we put in every city in the whole country, we could have a very, very, very wide. And now it's really hard to compare January with February because there's 3,000 cities in between. So the distance you have to go really is the same distance as when we had February over here. So that's not good. Whereas if we actually do this, and then we actually say that's Davis. Okay, this is Davis. Okay, if we just draw the points, then life is good. Because that we can now make comparisons. So I've gone from this. If you have this, so to bring in Davis, you have a second one of these, and now you have to start comparing all of the different cells one at a time. So we went to a bar plot, and then we grew the bar plot to actually have bars side by side. Anyone want to up the ante on that one? Thank you. Okay, we could stack the bars. Okay, on top. Okay, that's always fun. Okay, but so this progression from here to here to here, where to lollipops. Okay, we could put these things side by side. Yeah, we could put them side by side. Okay, but then all the way over to here. Okay, where we now actually get just here's your date of month, and we just now have these 2 points. One for Davis, one for Austin, another one down here, and so forth, okay, and then one here. Now the thing about this is the way I've drawn it is this is for Davis, this is for Davis, and this is for Davis. So this is a crossover. So this is when I actually connect the lines. I get even better stuff going on here. Obviously, this is all obvious except for I see so many people just say plot, and if you do this in Excel, after 12, 15 clicks. Get a stack bar. Okay, we'll get this. They're working on it. Okay, but this is actually this is a choice. You're actually deciding, and it's not very hard to do with many different pieces of software, but it is a choice as to what you actually want to compare. Even just it's obvious that you put the date down here, but it's not. You can actually do different things. It's actually really not that you can have to do this. I can quite happily flip this, and here's your dates, because these are months and these are categories. We probably want to actually put the counts here, because we measure everything on the horizontal axis, okay? And we always do this, and then we go to the y-axis when we have 2 variables. So it's kind of funny, because remember the histogram? That's on this axis. That's the actual value here. For some reason, many people want to flip the axis to get the actual values. If you have the counts, they flip the axis, which is odd. Everyone knows how to do it. Everyone knows that we're doing it, so we accept it. This is why we use bar charts. Okay, because everyone accepts it except for it's not right. Okay, so yeah, I would just go straight to a scatter plot. The answer to almost everything is a scatter plot, and that's actually why we can do something. Why? Because there's so few elements. And then we have these annotations in there with the lines, and that's my attitude towards everything. So I'll give away the answer. We know how to fix everything. Okay, you know, in general, almost everything can be mapped into a dot chart, and you're getting what counts, and okay, which is a scatter plot, but it's technically a dot plot because it is actually logically different things that counts.
So the one on the right, that's the one we said dot chart on the right side next to the bar. This is the
This is a lollipop plot.
It's lollipop.
Technical. There's a whole, yeah, they're there. They can be useful. Again, going back, I'm throwing out lots of things because I want you to think, I want you to argue. Okay, and you say, you're wrong.
What was the scatter plot? This dot chart, well, you call it something that I call the scatter result. Is that something?
So a dot chart, so the difference in my mind, and again, it's pretty good. We'll talk about this next week where we talk about the grammar of graphics. You can build a dot chart. Basically, a dot chart is a specific scatter plot. Okay, and that's oftentimes this is because we have categories here. Okay, we have categories. These are the months. Okay, and we tend to. And then we have a count to it, or we can have a dot chart for percentages or rates, and that's fine too. But we tend to be thinking of categories, so these are not continuous along this axis or this axis. And R tends to actually think, and not that that's the defining standard, but R will actually tend to draw dot charts horizontally, so the counts go this way and the categories go this way unless you tell it to flip. Okay, whereas a scatter plot, you have to specify what's X and what's Y. And you have choices, which is a very specific type. But it's analogously a time series of a scatter plot, except for it's very special. It's got the notion of time on the axis, the horizontal axis, but it's still the same. In terms of construction, it's a scale and another scale, and then we have Cartesian coordinates. Okay,
but maybe an embarrassing question, but this dot chart is actually there's a command line. I mean, if you want to go.
There's dot chart, and then there's dot chart, and then there's dot plot. R has the three different graphics systems that you can make plots with, or at least say three, and they all have slight variation. Yeah, there's a dot chart, and you can give it one or two variables, and it knows what to do. You can give it lots of variables, and it will actually do this sort of thing where it knows to say these are pooled together because this is for January, this is for February, and so forth. Yeah. But again, you've got a choice as to how to group them potentially.
Because I've been trying to use like plots, basically what you just did and dot chart using plot in Python. You know, like you can't say, but I don't want the lines.
No, and that's the how. That's what we're not going to touch the how today because you descend into that really quickly. It's how do I actually get the line in place as opposed to hang on a second. This isn't the right thing. So this isn't getting my message across. This doesn't have the right elements. That's why I'm asking you to think about what the plot would look like, sketch it out on the back of the napkin, okay, and then figure out how to make it. But yeah, I need to plans, and then you do find the software, and then sometimes it's pain. But no, R has these dot charts of many different varieties, and it has grids. They often add grids where you actually, especially in this case, where you sort of you put this dashed line so you can easily figure out which one goes with which category, which can be helpful. It's a visual cue that helps people interpret and actually make the connections. Or what's another term for it? These grid lines. I can pull it up. I can show you one of them. I can keep it over. Get my exercise again. So what I'm saying is basically we put these, you'll see this a lot in ggplot, they're all over the place. These are grid lines, if you will. So they're very helpful so if you have lots of these things, and you have this, and you have this, and this, these lines help you to actually figure out which one to go with which. But if you don't have that many of them, so it gets nice and thin, what's another term for this, for these grid lines, when they don't help you, when they're not necessary? I'm being cryptic. Distraction or?
Chart
One person's chart, another person's, oh, I love those grids. So I have another, I skipped a slide here where there's four beautiful plots with these nice smooth curves. There's no data on there. It's actually sort of they're idealized curves, and there's five curves on each plot of four, and there are about 50 grid lines in each dimension. So it's like, this is nuts. This is all it does is actually waste your printer time.
Can I ask you a question about over when you switch the dates of the counts?
Yes, please.
Because it gets to your point with the grid lines, like if you had January on the bottom and December at the top, I think like to my eye, it might be helpful to have the grid line, but if you need to have, so if you flipped it, you probably wouldn't need the grid line because you could kind of see on a relative height which one's higher or lower. Is there some principle that guides like if you have to put a grid line in, maybe you should switch your axes?
Well, it's not. I don't know why I didn't use that. Yeah. Is there a principle? So, well, one of the things is, and this again, I'm trying to be annoying today. So we'll talk about this next week. And also, it's complicated. It's seriously complicated because what I would do is I would actually. It depends on the resolution of the screen I'm looking at this on. Assuming I'm looking at it on the screen, because I just make this longer. So I'm basically going to change the aspect ratio. Mm-hmm. Okay, and this is important. I mean, choosing the aspect ratio can be. I have several examples where it's like, oh, I blew it. I got the aspect ratio wrong. If you flip it around, I don't know. It's funny because this again, in my brain, this is the logical way to do a dot chart because this is the value going across. It comes from a histogram. That's the value going across. But every time I look at one of these, I actually want it to be the other way around because I want to actually look at the heights, not the lengths. And it's just that's my perception because I'm used to it. If you flip it, so you want to point to my head, but let's tell you what the so you're saying. So remind me, say again exactly what.
So instead of having the count on the bottom, we have the date on the bottom. January.
But why? Because you were sorry.
Because of a grid, having to add a grid.
Yeah, but do you actually think you can say up? I mean, so it depends on why if I just switch over, does it make any difference? I'm not sure why it would make it. I mean, this is entirely symmetric. So are you telling me that there is some cognitive thing going on that if you flip it, you can actually see?
Well,
is it because the number of points?
No, because of the data point. Like if I wanted to know, like, oh, I think 4th of July might be a big DUI year or something, and I wanted to find July, like it might be,
So
I don't know.
So good.
Or maybe tradition or convention or whatever.
So this is exactly what I was trying to get at. It's very, very vague, generic terms earlier, and I was hoping somebody was going to actually break this. What is the purpose of your plot? You're now telling me that you want to be able to look up a specific data quite quickly. In which case, then, this axis is more important because that's the way we think, analogous to the histogram. That this is the one I'm most easily able to navigate. Right? And there, your purpose there is like, that is the predominant axis that I actually need to deal with. And that's the purpose. And that means you need to actually change the plot. Okay? What we do, in my mind, is because of real estate and all that sort of stuff, we actually say, I'll just make a plot. Any idiot can actually figure out when July 4th was, but they're going to have to do more work. And if they're going to do July 4th, let me do July 4th, let me do Thanksgiving, let me do Christmas, let me do all these different holidays. Hang on a second, now I'm doing a lot of work to actually look at these things. So then it makes sense to actually flip the thing because the primary purpose is now changed. Okay, or maybe this was just a default, and we're never going to really negotiate this horizontal axis. So that to me is a very good example Where if you know ahead of time what this plot is going to be used for, you should actually just do something very simple by actually flipping the axes. And yet we don't. We just leave it to the reader. What else will we do, by the way, for that?
Highlight it in some way.
Yeah, because you have a question now. So if you want to draw people's attention to July 4th and the certain holidays, let's start putting in annotations. Okay, you can put it in here, and you put in July 4th. Okay, and you put in these other ones, or whatever. Just even put in arrows or whatever you want to actually identify the point, the actual individual point of view. Again, if that's the purpose of what you're trying to get the person to focus on, you better do it. Okay, because I do have this impression that people say it's a plot. I'm not allowed editorializing, and yet you are. You've already editorialized a lot, so you might as well grab their attention and tell them what the purpose of your plot and the message of your plot is. Okay. So what's wrong with this? There's a lot or not.
Maybe easier to say what, right?
Yeah, that's right. Oh, I got it better. I got it better. It's next. Okay, so you see, tell me so let's be positive, okay? What's better about this than this?
Area you can compare. The pie chart at least has an area you can compare.
Are we comparing areas in pie charts?
Yeah, how big is one compared to the other?
Is that the way you do it? The social parts, right? So is that how you actually, do you compare areas or do you compare angles? They are proportional.
Yeah.
But that's not true. I've had it somewhere.
The two-part workshop.
Oh yeah, it's good off a lot. I have a really good one where in the area. So if you take this and you turn it on its side and you have a little curve to make it look smooth and nice, then it's not angle. Yeah, it's not angle. It's like, oh my god, but I've seen one. Okay, people get the angle. I told you. Just keep it faithful. Okay. So yeah, so it is an interesting question. Do you actually compare the area or do you compare the angle? They're the same, okay? The same measures, but what can we actually encode or decode more than points? It is actually different, okay? This is this principle here. I mean, all this stuff is just knowing. By the way, okay, well, we'll get that in a second. Okay? So this is one of the worst parts about this is this part. Okay, and it goes back to this principle, very simple principle is how many dimensions are there in this data? Two. What, two? Category count. Okay, now so where's the third one? This is the third. This is the third. And of course, the even more egregious version of this is when they explode the mind. Okay, when they actually have all the bits coming out for dramatic effect. Yeah, because why is that bad? Because you guys did that earlier. You were guilty of that same thing too. All of you, every single one of you was implicated when we actually put a gap. When we put a gap between January and February, you all said that's the right thing. So the principle would be let's put a gap between these things, just so you can see them better. And then there's no chance that you could possibly confuse. So why is
Isn't there something you said putting the gap between discrete categories like
Yeah.
lots of
Yeah. No, exactly. Yeah, no, there is. So let's put a gap here. No, there is. But again, this is a conflicting principle. Over here, we could have a debate, and I genuinely think it's worthwhile having a debate in your head for 10 seconds to say, am I doing the right thing? Because I suspect that people have no debate for 0 seconds. It's not like 0.1 seconds, but it's 0. It just never happens. And this is, we've got months. Should they be continuous? Yes, they are. It's time series. But no, they've got a different They've got a different number of days. Oh, I don't know what to do. I should think about this. You know what? It doesn't matter because the big picture, it doesn't change anything. That's fine, but at least you thought of that, because a priori, if it does make a difference, you've got a problem, because you now actually might be making some confusing remarks, should we say. We did like a gap here for discreteness to actually say, do not treat these as a histogram. There's no chance we can confuse this for a histogram, so we can do this. But the trouble is, if you put a gap in here, if you make these explode, you have now broken the comparison of the angle. Okay, you made it further away. Again, that principle of you put everything as close together if you want to compare it. So if I have two lines, you know, are these? So you can see these two are the same. Okay, are they the same? If you take a cold look at them, you know, here you have no idea. So you put them close together. You want to keep these close together. You want to get rid of this stupid thing. This plot is still there. But what is this plot telling you? Okay, you got 5 minutes. It's going to take you almost 5 hours. Hopefully you won't. Tell me what the message, or tell me what they're trying to convey here. Because again, the plot doesn't.
Very few addresses own most of the paper.
Very few addresses. So yeah, so quick, I think, because then you actually have to figure out what's going on. Again, hopefully there's kind of context to it, so at least you know they're talking about Bitcoin, IP addresses and Bitcoin and all this stuff. So how would you plot this data? So I told you everything's a dot chart. Not this thing. They're close because they're scatter plots and vectors. Well, that's a good way of thinking about this game.
It's one of the 2 dimensions. It's proportion of addresses versus proportion of Bitcoin ownership.
Proportion of addresses to proportion of. I had a picture of it. Yeah, so we have. I can't remember which slide I'm giving, which one's up. Yeah, I mean, let's think about this, which is the proportion. So, and essentially what I want is a cumulative plot here, which is I want to get it to 1. I want to see how close, you know, how fast it rises, because as I go across the percentage of addresses, and then the percentage, so it looks like an ROC curve for anyone who thinks that way, you know, okay, all this stuff. So we're going to draw a plot of IP addresses, the proportion of IP addresses, the proportion of Bitcoin. And if it's very small, and we're way up here, that's very small proportion own a lot of Bitcoin. So if it's a curve that goes like this, it's very heterogeneous, spread out. So we can see that because this is just a cumulative plot. We're actually talking about right. There's a great there's a website which it's in the links for this WTF.org. Okay, and there's a lot of plots there just for. Again, it was easier at the beginning, but it was easy to find really bad plots. Now they've gotten better than they're picking up plots that I can't actually find much. But this one was good. Okay, so this is not good. Okay, this is another classic, an old classic. You can tell because of the hideous print. This is a printed thing. Appeared in the Washington Post back in the late 70s, 79 was. So
Yeah.
tell me what's wrong with this. I mean, when I was looking at this, I'm like, oh, good. It is later. So bad plots went with other social issues. Yes, but I will say this again. Let's be positive because everyone can rip a plot apart. Okay? It's extraordinarily well sourced. I mean, there's a lot of contextual information as to who they're comparing. There's very little left that you don't understand. Like you immediately said, there's no women involved in here. You know, that's good that they told you that, as opposed to that you actually figure it out. So that's good. So that is good. That's positive. See, I still love that. What else is positive enough? I'm serious. No, that's the data. They couldn't avoid it.
No, you could. You still showed us sometimes they avoid the time.
Well, that was this is better. The gap is increasing over time. Yeah, but that's good. It's a linear. I mean, this is going up linearly, and this is going up linear, but they have different slopes, so we should figure out this. It's telling you that they're basically just going up at a slightly different rate, but then that's fine.
It's nice the category labels are on the one area rather than the legend off the side.
Which category?
The top space, the zone position, inverters.
These two things? Yeah.
There.
No, yeah, I mean, looking up a legend, your brain has to switch over. The good thing is that they're actually, because they're not flipping all over the place, you only need to look up the once, so it doesn't matter, but that's fine, that's good. I also like the fact that you actually have the numbers in here. Why not? We're back to bars again. I don't know what the width of the bar is. It's essentially the year, so it's okay. Okay. I don't like this. I don't like the black and the white thing. It's very hard to read this thing. And it's hard to read because it's scanned so bad and stuff like that. But it's a little harder to read those numbers and all that sort of stuff. But that's because they have the numbers. Now, tell me how you would do it better. Oh, there's one other thing, by the way, that you're going to have to tell me immediately that you have to get rid of. Hard to get rid of. Wait a minute, what if they even turn around as they got out for something like that? I mean, like, that is chart jump for something. Okay, that's the star. So that's kind of wacky. Okay, so that's how would we make a plot? How would we make a better plot? What's on the horizontal axis?
It's time still. And it's nice because you can actually pin them to the specific year, whereas these bars, like, there's gaps like 8 years and it's 4 years, and it's inconsistent.
Do you think that's going to change the message then? Because I'm trying to actually get rid of the chart junk. And we've sort of said, there's a widening gap. This is the salary gap. Okay, you're seeing it, but they're in there.
Yeah.
So this is that. Okay, this is a better plot, yes? Happy?
Yeah.
No. Not even remotely close. This is the same plot. Okay, okay. Because this is the real plot. Okay, and this is not that they're going up at a different rate. They're going up in a different way. This is exponential. This ain't. Okay, and that the original plot did what a lot of people do intentionally. I'm going to give them the benefit of the doubt and say it was a mistake. But this plot is also something you can do in R in a heartbeat. Okay, you said date. I was going to pick you up. No, it's here. The label. And if this is a categorical variable in R or Python, it will just do a dot chart because it doesn't know the differences here because you're not using it as a continuous scale that actually measures time. So the difference between 1939 and 1947 is the same as 1975 to 1976, which is of course complete nonsense. And you wouldn't let your 8-year-old child away with that, but we do in the Washington Post.
In one case, we're taking the coordinate to the axis of the default variable assumption. I mean, not this one, but the next one.
This one?
Yeah, but taking x and y.
In what sense would it give you a difference?
Amount in the y.
I'm not sure. What do people think?
Is it if you usually put the time on the x?
It's usual. This is the problem that we've got with graphics in my opinion. We have a lot of built-in conventions, and this is this concept of be surprised. If you go and surprise people, I have to actually have some sort of cognitive overload to understand what's going on, or I may misinterpret. Okay, I mean, because how many of you realize that these were not consecutive years, sort of initially when you saw it? Problem is, there's way too much information here. That all the chart jump, you were last thing, I mean, again, it's the quality of the scan as well, but also the fact that there's all black here is detracting from actually focusing in on that text. So it's very, very easy to go wrong. It's very easy to think, oh, I know what that axis is, it's time. And it's not, it's the amount, it's the dollar amount. So this is the trade-off you have. Does it actually illustrate the effect, and will people see it? You may actually be able to show something better, but other people may not be able to encode it better, which is a problem. That's a real problem. Should we take a break for? Why don't we take a break for 5 minutes and come back? Nothing wrong with this one, but it doesn't necessarily yell out what you're supposed to look at. Again, context means absolutely everything. Some of you may have seen this plot before. I won't obligate you to show it because it's supposed to be a classic. But here's the raw data, and it is a classic. It's a really beautiful plot, and it's done back in the 1800s, and not with software, as you might imagine. But these are these tables. What you've got, this is Napoleon's Russian marches. So you actually got the location and the city of where they were, and you've actually got, this is where they were as they moved. Connect up here, we actually have the dates where they were, and then we actually have the number of people in the army that remained. So so what do you do with this plot? I will, if you would like. There's several places we can go to, which is a catalog of all plot types. Just for fun, I'm going, okay? So we can go through that if you'd like. So should it be a scatter plot? Should it be whatever you want, okay? If you want, we can go through and look and see the range of plots that we might consider. Or, do you want to tell me how you plot this? Latitude and longitude. So, okay, of what? I got latitude and longitude, longitude.
Like on that.
On the map? Okay, yeah, on the map, latitude. So it's a scatter plot. Lat long. Scatter plot. And if I want, and I can get fancy, I can put a little map of Europe on the background. Okay, it's okay, complicated because then I can't see the points, but that's okay. So we can change the color to make sure that they don't occlude, they don't blend in with the background. Okay, so I could do that. Or, and then what else am I missing then?
You're missing temperature
I need to get the temperature in, so how can I do this? I could put latitude and longitude in. Okay, so that's kind of going to be the content. So it is a geospatial thing. So that's probably going to be the defining, not necessarily. Again, I'm begging you to say, don't do the obvious thing until you've thought of an exception, an alternative, and then realize that's a stupid thing to do. I'll go back to the obvious thing. I mean, because we could actually just, display time and temperature. And I'm going to give you another option. This doesn't have to be one single plot. It could be multiple plots combined together into a big plot where you can actually see things. And that's hard because now you've actually got to tell people how to navigate the different elements of the plot. But if you do it well, you might be able to do it. But hey, one plot would be great if we can condense all the information in an understandable, comprehensible manner. Okay, so what else would we do?
You can scale the dots based on the survivors.
Pardon?
You could make the dots bigger, smaller based on the number of survivors in the scatter plot.
The dots bigger or smaller? The dots. So you have dots. We got a scatter plot. So we're gonna have dots. See the little pens over here. So you have a dot, and you're gonna say, oh, for the survivors, they get bigger here. Okay, so this brings up another principle. So let's say it's that. Okay. How much bigger is this one than that one? Because I need to be able to see 3,400 down to 2,800, and I need to actually be able to tell that, or do I? I do. I don't have to.
You don't need to know it's exactly true. You just need to know, like, man, they all died.
This is Kristen's message for the plot. They all died. Okay.
The DSI television.
Yes, it is. Yeah. Yes, so that's the message. Okay, well then we just go for just 2 points. And
Well, and size gets dramatically smaller, so you can see, that was dramatic.
so the trouble is we don't do very well with this in being able to actually to pick up the difference.
So we're getting there soon. But and again, I'm jumping around intentionally. We'll tie it all together next week. But we're using area here to encode as value, and humans do not do area well. If we go back to the scatter, if we go back to the pie chart, we don't do angles well either, and we do them well. We just don't do them as well as heights. We are very, very good with heights. We're also not very good with this. We don't do lengths that aren't perpendicular, okay, or parallel to each other in the orientation we're looking. We do okay, we just don't do as well. In other words, when I plot this and you decode it, you have errors, higher errors, okay, and that's the principle we have for graphics. And in terms of how do you make a good plot, you use things that you encode the data on the plot in such a way that maximizes or minimizes the decoding error. And so people have done experiments to figure out what do people do. Everyone's different, but there's general consensus there. That heights or lengths are very good. Slopes are not too bad. This height and this height and this height, that they're harder to actually figure out than these three heights, where they have the same common origin. That's why we hate stacked bar charts, okay? Because the bars start at different places, so you have to compare heights from a different origin after the first one, okay? The slopes are not good, angles are not good, or aren't as good as heights, so therefore, the thing that's most important we use lengths for, okay? We can do this, but by the way, which should I be comparing? Area or diameter?
Area. But it sounds like the area is easier to interpret.
Yeah, but that's not what we're seeing.
Yeah.
So we got a problem because we're not using it. We're not encoding it. Again, it goes back to the pi area versus angle. They're the same, if you will. But unfortunately, they get squared, so you're out, and then now we've got a bigger error because we're squaring the error, and that's not good. So this is not. If this is an important feature, we probably want to actually emphasize it slightly differently, because if we actually want to see that this is and again, if we just want to go trying to get started off big and went to nothing, then we don't really care. It's just a massive change. If we want to get down, we could actually decode this by saying this thing here is 3 times as big as that, or it's 6 times as big as that, and you want to be able to reliably decode that, then you better probably pick a different mechanism, different attribute. Okay, so that's fine. So okay, scatter plot, x1, your mountain map, we can code it that way, of the locations. How are we going to get the temperature? The color will be good, and that's nice because we can go red and hot and go down to blue, okay? And so that's fine. Even a natural color that people are somewhat familiar with. Okay, then there's also, what else?
Advance retreat.
There's the directions we're going, okay? There's actually also a bit more to it because I'm going to show you. You can also see there's a group because the army wasn't just walking along to a big group. They all came from different places and combined and split up and went to different places. So this is a plot that somebody drew. And again, it's 2 plots, okay, but they connect. Okay, they're connected. It's not. I think what I'm trying to get at here is this is not a standard plot. Okay, there isn't a function called plot, that just says take these things and do what I meant. Okay, this is, you have to seriously compose this. Okay, and then so this is the start. Okay, and you can do better than this. People have actually enhanced this to go even further along. But you're sort of seeing these groups coming in and joining and departing and so forth. And as we go along, this is a guy called Menard who actually designed a lot of different plots back then very effectively. Okay, and so then you can sort of see, and then here's the retreat. Black, we change color to actually to retreat. And this here is, I'm trying to remember what this is. Is this the temperature as we go along?
Yeah, things going up. the trend temperature is negative.
So that's the test temperature. Versus an
Oh, you're right above the table.
I'm too close.
And I think it's in French, but.
It is there. It better be in French. I've got the wrong one. Okay. Yeah. So this is minus. But how do you improve this? You can't. It's the best plot. How do you improve it?
Just radio.
I didn't add
Right. Just the text of the six. Walking through that.
the direction. I mean, it wasn't easy for me to follow. I think it starts from there where it ends.
And there is some contextual knowledge where you know that for those people, and so again, you can assume in some regard that they know people started in France and they moved across to Russia and they came back. So there's an implicit direction, but you're right. You could put that in. A legend would tell you that how to interpret this. You could have arrows or something like that. You could also, somebody has actually changed the color line out here, which is to temperature. So that you actually see the change in temperature, which is not bad. You know, if it was me and Archie was doing this, I should change the color. Oh, that's a bit hard. Every time I try to make one of these, it takes me about 3 or 4 days. So I'm giving up here. Now, we have computers, so we can actually experiment, which is really, really fun. Important. Yeah. So, but again, what I'm really trying to get at is that is from here to there is an awful long way of thinking. Okay, and the benefit is somebody's already done it, so we should be actually looking at a lot of plots and saying how do we extract some principles, or how do we extract some creative ideas so that we actually liberate ourselves from simple scatter plots. It is a scatter plot. Okay, it's latitude, longitude. Okay, but it's a heck of a lot more. And it does require some, actually saying, I want to build something different.
You see, I'm having trouble reading. Are those rivers and like landmarks that he's included, like location?
Yes, some of them are, and there's some annotations going along that tell you this. Is very hard to read this thing. Yeah, it's very good. There's information about extra information. What you actually see, I'm trying to figure out where I will see it here. There are certain rivers that they crossed where they lost almost 90% of the group were gone in one crossing. It was horrific. So there's so you want to see these. This is why you need the geographical component to it, because there's interpretation that you can easily pull out. It'd be nicer with these days. What we do is we actually pull down satellite image, pop this on top of the satellite image, and do it in Google Earth, so you can actually sort of change them, see this evolving over time, or whatever it is, just animated. You could do all sorts of fun things, but this is a beautiful static plot that actually does convey an nuance. Yeah.
How can I see the scale of the army? Like, it gets thinner and thinner, I get that, but what does that mean in terms of hundreds of thousands?
Yeah, so he hasn't actually told us that, which is it's actually in here. This is the number of survivors. In fact, actually, this is an odd version because this is the number of survivors. I'm trying to say that is the starting. That's the starting value. Yeah, I mean this sort of thing probably needs to go to a scale. He has these. I don't know. I can't read this at all. I can't remember if there's a scale that tells us what the initial value is. Okay, but you're right that should be included there too. But by the way, you notice we were talking about these circles over here. We got what do we use to show the number of people left in the army?
The way.
Which is a distance. Okay, we're back to length again, because we can handle length very quickly in our brain correctly. And there's so this we can tell that this. This gets to your point, Christine. It's like, yeah, this is kind of different from this, and it's it's massively different. And you can sort of see that this is only whatever 20 and you can do the calculations reliably. So you can sort of see that you can infer the weight because they're not circles. We actually can do this reasonably reliably. Yes, there are definitely ways to improve this plot. I'm just like I'm when people say something the best ever. I just almost by definition. Okay, so this is somebody else's plot where they actually did add in color for the temperature, and then they put in the legend for explaining how big anything is, the group size, so you can actually sort of compare the heights. What about this one? Good or bad? I told you that last. I've given you some bad ones. I've given you some good ones, and now I'm giving you. You tell me. I had a professor once who used to do that. She's like, let's read a paper and discuss it. I'm not going to tell you whether you trash it or not. What's your initial reaction?
What's on the bottom?
Relative humidity as of. I can read this on this screen. I couldn't read it earlier on, actually. This is the precipitation in inches. These are the months. Okay. This is okay. This just to help you read it. These lines here, these sort of curves here, are line indicates normal low and indicates normal high. This is it says July 21st, it was 102 degrees in New York. Okay, this is the low on December 25th at night. Okay, you've got some information about the annual temperature here. This is just aggregated over the entire year. This is per month for the rainfall. Were there any days in January which were warmer than the low in summer? Somewhere generally fine. Yeah, you can see it pretty quickly, and you go across. The grid lines do actually help you here a little bit, including stuff. You can sort of see this is the start. This is the low and the high for each day. So you got 2 observations per day. So you got something like this. There's 2,221 plots data points on this plot. Okay, that's a multiple. That's too much. Except for it kind of works. You know, you can sort of see when we were out of the norm. Okay, you're above here, you're below there. You can see when the days. You can see days when you were kind of okay. We were above the high, the normal high, and below the normal low. You see, and you can sort of see how things. How does the precipitation change with respect to time, for one, and also the connection between the highs?
March and April were wetter than normal years.
Precipitation, these are yeah. So we can above here. So it seems like about 6 months is above, 6 months below.
Is that the difference between from normal, or that's just the absolute value?
This is normal. This is actual and normal. Yeah. So this is
okay.
Yeah. So then this is the comparison. It uses bars gratuitously. It uses textures gratuitously, except that they help you because they're so busy. It may actually help us. I don't know. We have to think about it. Okay. But it's a pretty effective plot. Yeah.
Oh, I'm curious about the changing fitness of the temperature observations. Is that just function that makes so many data points, or is that varying fitness supposed to represent?
These guys?
Yeah, and the black lines are big.
From what I recall, this is actually, there's 2 points for every day. And when they start getting closer together, they start looking like they're just a big class thing. When they have very big extremes, they're consistent. Yeah, I'm not sure how that big. Yeah, I think. No, my yeah.
I feel like the inset on the upper left corner doesn't give me much information, and I would rather have that in text.
Yeah.
Just it's something else on a very busy map, or sorry, very busy plot that I think would be put in text.
It could be. I mean, it does. I mean, it's all. This is for temperature. I mean, it does say that it isn't an unusual. It isn't an unusual year. And it does provide some context here. But yeah, you're right. You could drop out without too much. But again, my argument here is when you think about this has got like the previous plot for the Russian Napoleon marching to Russia. It's 2 plots or multiple plots that are connected by time. This time is a natural connector here, but not always. You have 2 plots with the same horizontal axis or 2 plots side by side with the same vertical axis. The scales better be the same so that they don't get confused. But you're combining things together. This is a highly non-standard plot. Each bit is kind of standard, but you're combining them in different ways. You're adding these elements which require some thought about actually why you would put them in here. It's not particularly hard. Nothing is absolute secret, but it's I could imagine. That would be the first thing I would have thought to have done. Okay. I beg to differ. Okay, so so you have to think about what you're trying to get across. plots. And again, if we go back to this, is this for EDA or is this for exploratory data analysis? So it's something model fitting? Are we trying to convince somebody of a message here? This is kind of more of the overview, so just figure out what's going on. This is another plot. Again, I want you to, my purpose here, we'll talk about a lot more stuff next week. I'd love you to tell me what you'd like to talk about next week. Anyone know what this is? Okay, it's Caltrain. Okay, so this is actually from San Francisco to Gilroy. It's a time series, but it's a special time series. It's a train schedule. It's a table. Plot. Or not, but I can't show you this because it's too darn huge. Okay, on this screen, I pull up my tree monitor, I can get it all on the screen, and sort of, but I can't get the height because it goes on for lots of stations that it goes through. And this one says it's going north, it's going south. Here are the train numbers, and this is, I usually get the points somewhere over here. Here we actually have the stations identified. I take the train a lot. I know the trains, the schedule by heart. I kind of know when I'm supposed to get into these different things, but I have to look at the train schedule to know when it's leaving, when it changes the train schedule. Okay, so it's just a lookup table. The table is a good thing here because I need to know. Do all trains go at the same? Take the same time? They all go the same route, or do some of them stop early? What's the big picture here of the trains? I want to understand the trains. How would I display the entire summary of this? Because that's a lot of data. Anyone seen a plot of this before? Again, highly.
Oh, I've seen Tuffy has that really beautiful.
It's on the front cover. Oh.
Yeah.
Okay, I'm on Tuffy's book. It's a column Mary plot. After the guy who wrote the column. Okay. And this is kind of very simple. It's just, here's the time of the day. Okay, here's the station. This is the original one from Paris. Here's the time of the day, and what you actually can see is where the train is at any moment of time. So it's actually a very simple plot. Again, afterwards, that's what you all would have done. Okay, it's not particularly hard. What's this? I don't know what this is. I'll tell you, it's the same plot. It's the same thing. It's a train schedule. Can anyone tell me what the red line is? Pardon?
Is it an express train?
It's very special. Back in the 1980s, TGV, the train at Rome-Yes, okay? They introduced this very, very, very fast train in France at this time. Look, you can see so clearly that how they cut the time from 9 hours to 3 hours from the whole day. They only ran once a day. And you could tell this. Okay, it's a very simple plot that grows. You can annotate it more. But it's a very, again, very non-standard plot, but it gets you there. And then somebody else there too. This is the Gilroy, San Francisco Gilroy version. This is actually done in they call D3. It's an interactive plot. Okay, so you can actually go in and hover over things. And you can see that you can select differently. But these are color coded because one's a bullet train. It's going to pick that up because it actually has different slopes and so forth. And which ones don't stop at certain stations. Okay, there's one other thing I wanted to show you, which was. Over there. Some of you may have seen this before. Oh, it's old now. Have you seen it before? That's not a good way to see this on this screen. This is again, I'm just trying. Really kind of sorry I'm belaboring this, but people don't think enough about plots and think about how to use them in a different way. Just so you take the old things. So this actually was a professor, Hans Rosling, who public health, and basically went in one day to his students in Sweden and so said, hey, what do you know about X, Y, and Z, like child mortality and GNP and so forth? And I suspect if I did that here, we'd all get it wrong. We all have sort of stuff that's based on 50-year-old sort of information. So what he actually did was it's an animation that in this particular case it's showing income and life expectancy for each country for which we have data, for which we have a lot. You can quibble about the quality of the data here, but these are this national data. And what you're actually seeing, and we can control all of this stuff, but this animation is is each point is a country. The color tells me what continent it's on. You clearly have the time going on here. You sort of see things rising. And this is a three-dimensional. It's a two-dimensional plot. Three-dimensional because we got the population, because that's the size of the points here. You've got color, 4 dimensions. You've got time, which is 5. Again, you can't put this on you could put it in on a printed page, but you got to have one for each year. That's a lot of pages and an awful lot of cognitive switching between. So this is a much nicer and different medium. You can also happily go over and say, hey, this is the. You can identify each of these things. You can look at individual ones. It's a very different medium. Okay, so it's unfair. You can't compare these things. You can change what the axes are and explore in a very, very different way. But this is actually, think of the message you can convey here. It is so rich if you actually compose it well. You've got a different set of principles you actually got to worry about, but it's not. In this particular case, it's extraordinarily simple to create. You create a CSV file, you upload it, and then you start, and then you okay, so like the software is simple, but you still want to be thinking about what you're going to do. Yep.
My question is about the circles here, because I can't help it. I kind of like the circles, even though I do appreciate what you're saying about height being more instantly intuitive. But I think what I like about the circles, and I don't know if other people feel this way, but relative to one another, it does give me information. I have precise information. Kind of like Christian was saying, like, oh, everyone died, or everyone didn't die. Fewer people died, but it's all relative.
Don't get me wrong. We have to do something, okay? And you've got to try to convey the right message. So essentially, we'll get there. Yeah, there are principles that understand. There's experiments being done. We kind of know what's going on. Length, we're better at decoding. So we use that for the primary purpose. Okay, so we're better at decoding lengths here and here, but this is a secondary issue. Okay, and we could quite have. So I agree with you entirely. What I'm saying. So you cannot tell very easily what the relative population between these two are. Okay, but that's not the purpose here. We could just bin them into low, medium, high. And then we could actually use a different glyph. Instead of a circle, we could use a triangle for one, a square for the other, and you would know which category they were in. And we might use a question mark, for example, if people have done this. I had an exclamation mark to beg people not to actually compare. So it's actually to say these are categorical labels, right? There's no height, there's no value associated with this except for qualitative value. You could definitely do that. Again, this is a misinterpretation. As long as you're not trying to actually get people to decode important issues. So this is what we've done, what's being done here, and when we did scatter plots, this is the third thing. This is the third variable. And I chose that variable to be represented by color because I didn't care as much about it as the other two in terms of the message I'm trying to compose. That's all we're giving. You can't beat this. It's really seriously hard to get 4 dimensions or 5 dimensions onto a 2-dimensional screen. You're gonna have to give something else. Okay. One of the things you can do is actually have panels and get, so you can split this up, as I say, by year or by continent. You could do that, but now you're further away from each other, so you can't make the comparisons as easily. So if your goal is to make comparisons, you need to keep everything close. You're going to give up. That's why I'm saying, if you go back to one of the slides I had, there's a lot of different criteria we have to take into account. My point is, I don't think people think very carefully about what they're giving up. And I would give certain things up when I'm looking at this by myself, whereas if I'm actually trying to give this to the general public, or if I'm trying to give it to other researchers, I might make different decisions because what's my message I'm going for, and what do I need them to decode? And the fact of the matter is, all I want to do is say, oh, look, this is tiny. Oh, that's India. This is China. Okay, I'm guessing. Okay, but I can tell I'm going for the big ones. Yeah, so somewhere in here, I think we're just about to have this discussion. So there's a bunch of guidelines. Okay, I'll give you these slides, okay? You know, identify your audience, identify your message, some concrete things, you know, put a caption on every single plot if it's in text. And put a lot of work into that caption. You know what the best thing to do is? Put a caption down before you make the plot. What have you seen? What's your message? The caption is your message. Then it better come with plot. Oftentimes we'll make the plot, we'll do a lot of exploratory plots, figure out what the message is, then write it down in English or not, any other language too. Write it down and then say, okay, how do I improve that plot to actually make it? I mean, I've got the general idea that I use the general insight. Make the caption, okay? If you don't have a caption because it's not part of the document, it's just that it's on the screen or something, at least put a title in. I can't remember somewhere. I can't remember if I put it in here. There's another little trick I do is I put the time on the very bottom corner, the date and time that I made the plot, because oftentimes I'll make 10 plots. I don't know which one it was. Like, is that the most recent plot? Okay, so I made some mistakes. It's like a version number on the plot, but it's really helpful. It's even better if you can actually put the code in the plot, so you actually can recover exactly what you did.
Sorry, what is title? So should we kind of write and what we conclude from this picture, what it should infer, or it's like we've got this versus this?
I mean, no, the title should actually get, so I mean, this is all based on, but I tend to think of the axis labels should give you the units or what we're measuring, so it's price in dollars or whatever it is, and then there's thinking about this data set that I have for here, which is you know, rental units and the East Bay. So the title is the context. It's rental units, rental prices in the East Bay, or rental prices over 5 years, or whatever it is, or you know, so you're giving the context in the title. So the title, you know, maybe if you don't have a caption, the title should probably also have a little bit of a message that actually you run out of space in this great caption, but you should really have a caption.
Like I mean, like the rainfall is increasing over 5
Yeah, I think that should be in a caption, but otherwise it should be increasing, you know, increasing relationship between price and number of bedrooms. You know, now you've got the whole context in there, and then you got you know, bedrooms and your dollars on the axis. If you don't have a caption, but again, why don't you have a caption?
if you're putting in PowerPoint, for instance. Slides.
And that's your audience. And that's again, it's a medium. It's also what your audience, what you want from the audience. Are you going to be talking around this anyway? So the title may not be as important. Sometimes you're going to give up the title because it's just obvious. You know what? Because you're talking about you need the real estate. So, but you know, well, in PowerPoint too, you may actually sort of give up. You may put the caption. Well, you may overlay the caption instead of later on. You can show them the plot and say, "Here's the take-home message." So again, you got a different medium. Now, there are times when you don't have a caption, which is you have a plot on the screen and you want to show it to someone. You better have to tell them what it is. Or you print it out and you bring it to your PI and you go like, here, and you go like, that's about what it was. I have no idea. So that's why I'm arguing you should probably just stick into put a caption, put some text underneath it, but at the very least, put some title that explains why you drew the thing and what the message should be. Think about the best type of plot. Go through the categories with the catalog of plot types. You know, it is totally obvious. Yeah, most people just go plot X, comma Y, and don't actually think. Think about changing the order in which you actually plot things so that things that are close together are the ones you actually want to compare. A lot of times what we do is we take January, February, March, but we actually want to compare different things. We should reorder the dates, so we should reorder not by alphabet, but actually reorder the categorical variables so that we can actually make the comparisons we want people to focus on. Okay, we'll talk about these perception principles, as I've already sort of alluded to all of them, which are use distance, use color and all these things, but you choose when to use them, know when you get confused. So appropriate scales are really important. Okay, we looked at log scales. They have to be meaningful. That doctor one where they're completely nonsense is really, really problematic. Okay, we've got all of these different things. Aspect ratio is an important one.
Okay, because you can actually mess things up if you get the wrong aspect ratio. Okay, the color blindness. How many of you are colorblind in this room? Can't see, can pick up between red and blue, red and green. There's different types of colorblind, but when you have a plot, you better be careful. Okay, because there's somebody in the room who has no idea what you're talking about. You can't see the difference that you're talking about. That's an issue. There are ways to actually deal with this. There's a general rule of thumb that says get the plot right with black and white. Okay, just start with black and white and do not get fancy with color until afterwards, because you are putting all your eggs in one basket with color. That if you don't have color, you're dead. So again, one of the principles I work on is I want to have minimal number of plots, minimal cognitive overload. I same with software. I want to know one function. I want to know how to do something so that not 10 ways to do 10 slight variations of the same thing. That's why we love the scatter plot. That's why we love to be able to go back to these primitive elements that make up things. We want to have we don't want to have a massive discontinuity when if I change the plot very slightly, slight message change, I have to go to a radically different plot. Okay, so we want to try to keep things simple, and that's one of these, which is just leave color out for the moment, then introduce colors in clever ways. We'll talk about color. It's a point which is that you've got 3 channels in color. One of them is hue, saturation. Hue is one of them, saturation of light. Okay, which correspond to red, green, and blue, but not really. They're conceptually different. One of them is just categorical differences, and the other one is different between them. And the amount of white you add, the amount of black you add, and we use them for different purposes. Okay, again, more for categorical variables, you just use the primary colors. Okay, but principle. Okay, this is one of them that I just want to say. I've learned this a lot, which is I think some of you alluded to this. It's really important to follow these principles and the rules, and then know when they're back. Okay, because they don't apply everywhere. Okay, we need to know when to break the rules because we know why the principles were there in the first place and why they do not apply. Or why, as you're saying, I like the circles. Yeah, it's okay because that's not your primary focus here. Okay, you can use things. There's a whole load of really stupid style guides for graphics, which are just absolute. You know, like it's just too much more complicated. That's why I've alluded to at the beginning to all these different contextual aspects. Okay, which is who's it for, where are we working, and all that sort of different thing. Here's a question for you, okay? I'm just going to quickly go through this, but again, belaboring this because I think because I see this a lot. People use why certain plot types come up all the time. This is one of the most common. So we'll start with the very basic stuff. Next week we'll just go through a bunch of other related stuff, which do with these. Decoding mechanisms and the graphical perception in humans and stuff, and a whole lot of different plot types. We'll also go through several more. I'm going to get you to draw some plots, okay? And one of them is serious. I don't know how to do it. It's seriously hard. There's just too many. It's too complicated. So we have to stack off and figure out how it's going to work. So I have this data. Okay, I have rental units in the East Bay, apartments and houses and so forth. I want to know how to summarize price. That's all. It's really simple. Unique areas. How do I summarize price? Get it.
Summary statistics or boxing is one.
Summary statistics. Okay. I was hoping I'm going to start with this. So not visual. I was hoping somebody was going to say the mean. What's wrong with mean? Standard variance. It doesn't tell me about the standard deviation variance. It also actually implicitly assumes that it's symmetric, because otherwise we probably want the median. And I don't know if the mean is relevant. The mean would be the nicest everyone understands the median. Fewer people understand the median. To do this, I actually need to look at the data to figure out what summary statistic I should do. So you seem to go around in circles here. So a plot does seem appropriate here, and also just the mean. The mean of the SD is sometimes okay, but it's just way too simplistic. There's a lot of stuff going on here. I got 5,000 observations all on one day or two. Okay. But one of the real purposes that I wanted you to ask was, what's the purpose? Because you just said 5 numbers, for who? Who cares? And what is the purpose we're actually going after? Who's the audience? If it's like, I want to know. is a huge amount. Okay, I just want to know the big numbers. Do I actually want to know the subtle details? So we have to figure out what aspects of this we are actually going to try to summarize. Big question. So what are you going to do? And I have, so you can jump right to the answer here if you like, okay, but I actually thought it'd be helpful to actually go through this, because I actually think there is, like this. Here is the data. That is a perfectly reasonable plot of the data. In fact, it's the default plot of the data. I said, plot the price, please, bar, and R said, and second. And I did. That is the price. I can change the label. Okay? And what it is actually it's plotting the observation number. And this is a perfectly comprehensive summary. It's not a summary, it's all of the data. People say plot all of the data. They say faithfully plot all as much of the data as possible. This doesn't actually necessarily summarize it. So that's a better plot. Yes. This is actually a better plot. It's a line plot. It goes back to what I was saying about we just think about things on the real number line. So this is the real number line. The y is irrelevant here. I had to put it on two-dimensional plots. Okay, so that's why I took out the axes, and it's fine. So what's wrong with this? We what?
Does it go with how many for each price?
We do. There's one.
It doesn't tell you the difference between now and
I didn't say that. I just said price. We're not going to actually. For this one, we'll get there in a moment, which is, and that's actually going to be an issue. When I start changing the question slightly, I don't want to have to go to a radically different plot because A, I don't want to find out myself, but I don't want you to have to start interpreting data totally differently.
But is that the case that it's just one for each price, or maybe this is just range of prices that we have?
These are, so this is the observed data. We're only talking about the observed data. There is a point here for every single house or apartment or any rental units that I got. The trouble is, of course, there's only one here, there's only one here, but even here there's two. I can actually tell there's two that are $1 apart or something. I don't know if ours actually just filling it in a little bit. I could change the plotting character to be smaller so I can see even less. Okay, so one way to go about this is just this, and I'm just the logic of this is, again, there again, it's all obvious. I think this is the thing that bothers me, but again, it's not obvious, unfortunately. Ooh, and especially the provenance of some of these things is kind of a bit weird. What I could do in this case, or in any scatter, if it was a scatter, not just the real number line, is I could jitter these values. Yes, well, jitter is just we add plus or minus epsilon randomly. Okay, so we can separate that out. It doesn't really. So in this case, I keep the price the same, but I just vertically plus or minus this. That sounds great. There's no point in this. We can do better than that. Why not just always why not just rank them 1, 2, 3, 4, 5 at the same price? Okay, there's a lot of having exactly duplicate things, and that's what this plot is, which is not a histogram, but why it's close. Okay, it's very close to a histogram. Okay, because it really is just this is like a stem and leaf plot. If you ever seen stem and leaf plot, how many of you have seen a stem and leaf plot? Why? Why does anyone see a stem and leaf? Who told you about stem and leaf plot? This is part of my problem. Some of this stuff dates back to the fact that we couldn't compete. Okay, so the stem leaf thing is for when we couldn't actually plot on screen. We had to do everything on ASCII terminals. Okay, and it was about the only way we could actually display things. That was before my time. But so this is like it. We just basically sort of at this price, these are the number of observations we actually had, and so on and so forth. So it is very much like a histogram. So then, why do we actually go to histogram? Who loves histograms here? Okay, so what's good about histograms? What's the difference here? Again, this is just the evolution of these things, and again, I want to talk about this because I think it's actually helpful because it's about how you move from not just which plot type you do, but why, and how would we actually change our thinking to actually make this better?
The number of bins, right? So the difference between these plots is like if you change the number of bins in histogram, you would move this part.
If I make the bins infinitely thin, so I get one bin per price, which is this is just too raw. I mean, the difference between an apartment that is $1,900 and $1,900 and $1,901 is just
they're two different prices. So we're not smoothing this out, which is, so we know about this, so we can take the bins here, and then now this covers multiple rental units inside of this, so life is good. Okay, it's fine. So what's wrong with this?
You're intrinsically losing some of your data, and sometimes the bin widths can be arbitrary.
They're arbitrary. It's like, God, I got to pick them. Well, I don't. That's the beautiful thing. There's so many different algorithms built into software that says, I'll pick them. And you can pick which algorithm you want to actually how to get the bin widths. That's stupid. They're too generic. So you actually have to start playing around with all of this sort of stuff, and then become subjective again. Okay? What does a histogram trying to do? So there's a lot of choices here about the bin width and the actual starts of the bins, because the bins do not have to be equal width. And if they're not equal width, it's the area that has to be, that people have to pay attention to, and they're not good at that because they think it's a bar chart, and they just actually look at the heights, and they make mistakes. So when you get exotic, you're not going exotic in a good way, it's just like, okay, everyone should be changing. We should not have equal bin widths down here because this is too small. We should actually just group all these together, but we don't because then people get confused. So what's a histogram trying to actually do? In my opinion, this is all my opinion. Pretty simple. This is the policy. Which distribution? It's a probability density function. It's a PDF, like a normal, like a, all this things. So why the heck are we actually calling this?
What is the likelihood of finding an apartment within a certain price range?
It's kind of related to that. It's kind of like, it's a probability density function. So we tend to think of these as smooth curves. Now we know they're not, because this is a discrete, its prices are discrete, but at our level, this is the Bay Area. It's continuous essentially. When you live, it's like, okay. So it's okay. So this should be a continuous curve, which means we should actually be doing something more like this. We should actually be computing the kernel density estimate, okay? Which is essentially the same thing as a histogram, except it's actually estimating the right thing. But look what happens. See this? See the gray one? Mm-hmm. So oftentimes this goes back to Kristen's point, which is like, well, if I want to look for apartments versus houses, I want to see two density plots, okay? Or if I have my number of bedrooms, I want to see four density plots or whatever, just and compare them to see how they are. I can overlay two density plots really, really simply because they don't hide each other. Histograms hide each other. People have solved this one by using transparency, but it's kind of nice because we're doing the wrong thing. They fixed the wrong problem, okay? Instead of they started off, oh, well, we're doing histograms, look, we have to do transparency so you can see behind one of them, but it doesn't really work. There's still all the issues with that bandwidth selection, or bin size, essentially, if you want. Here is how you do two histograms. What's wrong with this? This is what's called a pyramid plot, pyramid population plot, but it doesn't have to be that population that they grew up in, such demographics, the world of demography and stuff like that, because they're kind of cute. Are these two distributions similar?
Yes.
It's
a lot of work to do. This, because I actually have to compare this with this with this. They're not close together. This is breaking that principle of if you want to compare things, they're close together. They're close together, but the wrong bits are close together. I mean, if you just lay this over, oh, then the trouble is they hide each other. Okay, transparency will get you over that, but hey, we don't care. Oh, go back to the bars. The bars mean nothing. We're only interested in the height. Okay, so the bars are actually getting in the way of the plot. And that's why when we go back to this thing here, it's very easy to draw. Then just draw the density curve and we're fine. We could do that with histograms too, by just drawing the tops with no bars. Can we?
It's also, if it's exactly the same width, it's okay, but if not, you have area.
If they're not the same width, you've got a problem. So you can't, the histograms just do not generalize. Whereas this generalizes, you can actually you can stack many of them together. So this is a different way of composing this plot. So people also did this. Yeah.
So in the histogram, if your data point is not as dense as before, and how you gonna plot a continuous line? If you don't have, like, say, a price range, you don't have data, right? In the histogram, it's gonna fall into that.
Yeah.
The big one. But if you draw a line, I mean, how you go with this gap?
Well, but so what I'm suggesting you can do, I'm not recommending it, but you can do a histogram that looks like this. You know, you're just drawing this stuff, and then you would go down to, this would be your contour. If there's nothing in this, you have to go to 0 for that, whether you've got a gap. Okay, and then you can have another one, and you can do the other one over here, which is at least this way you're comparing. At least this way you're just comparing. You're not hiding things with bars. You're just comparing heights. You know, and now you're able to see this. You probably want them to line up by bars, not bar width. But yeah, you'd have to go all the way down to the bottom. So which is fine. It's you know, that's the reality of the data. That's the reality. Now, why do you have none there? Is it because you didn't observe any, or because so now they're assuming you should? So this is what people did in the past. Okay, and then they grew something. Okay, so this is a box plot for those. How many of you have? Who doesn't know that box plot? Okay, this is another one of two easy questions. Okay, this is the median. This is the 75th quantile. This is the 25th quantile. Some people put notches in here to illustrate how much variation there is in the median. Okay, and these two things are. You can never remember where these whiskers came from because the formula changes when you do something does it. So there's supposed to be there's a formula that sort of says beyond this they're outliers. So this is kind of nobody can define what an outlier is. You have to find that. So this is where the software is doing too much for you and nominally being just being a fire. Okay, it's not. So then people do this. Use one. Okay, so these are violin plots. What's stupid about these? Especially when they look like Christmas ornaments. So again, going back to this principle, they're not putting things close together. Okay, and there's a huge amount of duplication. I mean, like this side, by definition, is the same as this side. Come on, people. Whereas this goes back to this plot, which is just draw these curves. Just draw them as curves and you can superimpose them on each other. You don't need all this big wasted space. Yeah, color printers, you know, just color. So this doesn't seem to make any sense. Okay, but these evolved from box plots without people thinking about that's not actually a good way to represent this data, period. Okay, so and a lot of this, the reason we do this, John Tukey, I mentioned about EDA, he kind of invented these. Because he would actually sit there and he used to work in the same apartment as he did many years afterwards. He would draw you with a ruler. Okay, this makes sense when you can't deal with computation, but it's not anymore. Okay? I'm just going to finish up in a second. What's wrong with this? Again. They don't have the same starting place. Okay, so this is the problem. So that the widths mean nothing. Okay? The further up I go, the less likely the bars are to start at the same spot. So nothing else. You really want to reorder the categories to be in the order that you want people to compare them. Okay, that's important. And people don't. They just say, "Oh, that's the order because they're alphabetized," or something. Well, that's just nuts. Right? You're in charge here. Is what I'm trying to get at today. And not only are you in charge, you're responsible. Okay, so when it looks stupid, we're gonna make it. No. Okay, so but then again, so it's actually thinking that there's this one I like too. And again, but this is a stacked side by side bar chart. And these are this is male female. So it makes comparisons even harder because the things are further away. Again, there's some very simple principles. I mean, this is not rocket science, but yet I'm not sure if people actually spend enough time thinking about it when they make a plot and go, here's my checklist. Okay, so it is hard to compare. Okay, on what, and then again, go back to the question, what is it that you want to compare? You should choose this first yourself and then make that the most obvious comparison as opposed to, there you go, because in this plot as it stands, it's like you're doing all the work. The reader is doing all the work to figure out what the heck they're actually what they're supposed to look at. Okay. Compare B with E. Configuration. Hmm? 1 to 8. 1 to 8? 1 to 20? That's amazing. 1 to 8, 1 to 20, that's a long difference. You're sitting further away. Yeah, there is that effect too, but it's like, this is, and by the way, there's also some beautiful plots where pie charts in certain pieces of software come out as locals. Atypical because they don't preserve the aspect ratio. That's something that should just happen, but it doesn't. That's up to you. Okay, so 1 to 8. Okay, 1 to 12. So an average. B with D. 2. E with C. This is too hard. Which one is closest to A? Smart. One right beside. If this is the question I want, sort them. Okay. Again, though, a dot chart is going to get me a much easier. We're going to be able to estimate these ratios a lot quicker. Okay, and more accurately. Much more important is the accuracy. Okay, so this I'm going to just quickly just go through. So this is from psychophysics. Okay, back in 1975. It's various different things. It's the experimentation and some sort of theoretical ideas. This is what we're going for. Okay, if you give somebody an electric shock, okay, and you increase it by 1 unit, they think of it as being a big change, much more than the actual unit. It's 3.5, factor of 3.5, or 3.5 goes up. Okay, if you think about saturation in color, saturation is how much white we put into something. If you add a unit of white, people perceive more than that change. If you change the length by 1 unit, people perceive the length to have changed by 1 unit. This is good. That's what we're going for. Is that there is an actual correct interpretation of decoding. If you look at area, if you increase the area by 1 unit, we don't pick it up. That's why the circles don't work as well. It still works. It's just not as good. Okay, and then brightness and so forth. So these are actually these are theoretical, as you can tell, because they're smooth curves. But then this is what we actually this is the best. Length that's aligned, length that's not aligned is inferior to this. Okay, slopes. If you have to do this, it's not as good as either of these. If you have sloped lines, because we can't pick up the lengths as well, and we could show you some optical illusions that just to illustrate this. Okay, angles and slope are about the same. Are they related? Okay, but they're not quite, because this is actually measuring the angle. This is measuring the distance. In some regards, okay, area and color intensity are about equal in terms of people's ability to decode. Okay, and they are better than volume. People do not do well with volume. Why? Because area is squared. This is cubed. Good grief. Okay, and then we can do color hue in some regards. We can pick that up as long as the colors are actually done. So this is actually done by experiment by a colleague of mine a long time before I was around, and then somebody else, a guy called Mike Buckstock and others, did it more. This is how much error we're making. Okay, by the way, look at this plot. It's not standard. Look what they're plotting on the horizontal axis, which is it's a categorical plot. You have to decode these, and they know that this is in a paper where they can explain what this is. And you can sort of see that the log of the error is increasing as we go down through these different cues. Okay, using these attributes for these things. And what this means is, if you don't care about a particular feature, you can use this to get more dimensions on a plot. But if you care about people being able to decode the values carefully, you better not use these. You better be able.
In this perception study, is there any difference if it is horizontal length or vertical?
Which is bigger? Pardon? They're on the same, of course.
which is bigger. We all know which one is bigger. But it ain't. Yeah, I mean, and which is bigger? I mean, you can just do these experiments, and you can just do these. We just did the experiment with the angle. I asked you which slices are similar, you know, and this is you know, okay, so this is this stuff. This is, and when the, you know, they don't intersect. These are parallel lines that don't look the same. If I take this block away, you'll see that they don't line up. But I put the block in there, your brain just connects to them. You know, we have a phenomenal brain, you know, in terms of the visual system and the computations going on, and yet it's so easily fooled. And it's essentially what it is. But people are wandering around doing very bad things. So I take that away and they don't actually line up. You know, just quickly, because these are, I'm trying to get out the mad things. Who loves these? Everyone loves these. Why don't we love them? Because I just told you why we don't love them. There's so many reasons why we don't love them. Which of those cues are we using for this?
Everything.
No. What are we using?
Size of the models. Everything.
Actually, I don't believe anyone, I doubt anyone here could concretely tell me what we're using here. I know what we are. I said, look, code to do this. Is it height or area or width? Because is it the height? Is this a bit bigger than this, like say 80%, or is it the overall area? Because if it's overall area, I got a problem because they've got different numbers of characters.
Yeah.
Oh, but you know what? Which is it?
The height.
The front of the.
It's the height. But you all look at the area. Because that's what your brain is doing. This is a single unit, so you say that's big. So you have to tell people how to decode this, because it's not even clear what the rule is, let alone how even if you know the rule, can you actually decode it?
You're saying the length is not the same, right? We can't just do that.
You can do it any way you like, and so you need to know what the software is doing, that they're doing it wrong.
And here they're doing area, right?
And they're doing height, I believe in this case they're doing height. It depends which piece of software you use. Now you get the water. So tell me, so this is the yellow jackets over in France. This is 4 different days of Twitter. Okay, it's a good way to represent this data because it's words, all these words. Tell me, what topics changed over these years? So, like, we could be looking at the watchers, the little cars. Were there more or less fewer mentions of cars on the other days?
So it goes clockwise.
Yeah, why not? Yeah, it doesn't. I mean, as I said it doesn't actually matter. It's just I said this day are there more or less of what are the 3 different days? But yes, even that is not clear as to what the actual.
Could they be represented in the same part of the?
No, of course not.
So,
that's my point. It's like, oh my good God. Whereas, how are we going to solve this problem?
Change the blocks. Change the way to represent it.
Yeah, how? Yeah, that was the answer to everything. And then the second answer to everything was?
That's a good question.
What's your question?
What's my question? But that's just suppose we actually just we're going to do EDA, we want to look at these things. What's stuff? So there's a dot chart we say I'm going to add again because now they will be at the same point no matter what. Okay, so now if I actually sort of have an axis here, which is all the unique words, okay, and then over here I measure the counts, and I have a point for a lot of counts. I have four values for each word. Then I'll be able to compare them very quickly. I can even draw a line saying this is day 1, this is day 2, this is day 3, and I will be able to see the changes or not. But as it stands, this is unnavigatable. I mean, you just have nowhere to start. I mean, can anyone find the word voxer over here? It may not be there, but we can spend a lot of time looking.
This doesn't have to do with the photos of showing that.
Yep.
Because you you're just looking for the highest or the largest or the.
Yeah.
So
Why would I do that? I mean, why would I say now to figure out what the biggest are? Why don't I just say, here are the three biggest? And I just have a dot chart of those three, or but I just say in text, these are
just because it's fashion.
that's unfortunately the problem. I mean, this is useless in my mind.
This should because we're over 6 in there.
Yeah.
The which
Yeah, that emotion victims.
Oh, yeah. The movies are good. The beautiful thing about it is we have the movies. So one is text. Yeah. Anyway, so this one again, these defy some of the principles, and they certainly defy what is the goal here. Because if you actually have what am I trying to get across, there's no message here. It's just here's the dump of data. Why didn't you just give me all the tweets? You know, and I could have actually, I mean, we've thrown away information, which is like, I can't even connect with the same person. You know, on different data. Who's there? It's just, this is just a dump of data. It's not clear to some.
Well, they didn't do any of that really obvious because we see Gilets jaunes both, you know, in the like bottom left. We have both singular and plural.
These two guys, yeah.
There's actually a Gilets jaunes up there. You know? And then like we have like Macron that goes with hashtag, without hashtag, and then France. It's like really no data cleaning. Whatever they're got, they're just.
Well, these are hashtags. The other ones are actually in the text as words. So yeah, I mean, you know, making debate about that. Yeah, but
Well, why are some of them black and others blue?
just for contrast. I mean, you need a legend to understand that. You know, yeah, but then, yeah, this one's a good one. This one's like, okay, can you actually? It's not worth it. The screen is ripped out. Okay, so it's that. Okay, we might as well end there. We don't need to go so long. But anyway, if you have any thoughts about what we should talk about next week or beyond, just send me an email. That would be good. There's a bunch of things I have we can talk about, but it's much more fun. Yeah.